Okay, now as you come up, you can see you have igneous rock here. It's lighter gray. It's igneous. And here you have metasedimentary with a tiny bit of igneous. And this is where it gets a little hard to tell who's who without looking closely. Like this here, as you can see it shining, looks schistose. This is definitely protolith of a shale. So that's a slate. You can see more back there, and we're going to see some in a couple minutes. I need to get up there. Okay, that's the dam. Obviously, we're not going to be going over there, but I have been here before. We're going to look at this, right? That. I've looked at this. There's some down there we're going to look at briefly. I want to get some measurements here. What do we got here? Quartz. I think it nice. I think it's us here. See, now this, the protolith of this looks to be mostly sedimentary, at least over here. So we'll get our measurements and whatnot. The stuff right here could be igneous or highly altered metasedimentary. But that does definitely look metasedimentary. Looks like slate. And then one of these things is not like the other. Coal. Somebody dropped this here. There's no coal up here. Basically, north is behind me. Now, what's metasedimentary and meta-igneous here is real hard to figure out, because the metasedimentary, the gray wacky, is directly derived from the meta-igneous rocks, which were just igneous at the time. So it's hard to tell. So basically, behind me appears to be metasedimentary. This is what, the gray wacky, if we will. It does have cross bedding in it. That's what makes me believe that more than anything. You look at it under hand lens, the lithics are a little rounded. Actually, some are pretty rounded. But this here, that's also gray wacky. But where this little ravine is, to about right here, this is a meta-igneous. Well, we'll just call it a greenstone. And you can see there's quartz on it here. This is not bedding here. Bedding is actually, well, the orientation, you can call it bedding, is this way, about north 72 west consistently so overall, north 70 west to almost east-west. And dip is always to the north right here so far. So I'm gonna go up the hill and look at more stuff. Sarah. Now as you get higher up, facing east now, it's just down there, you can see the slaty cleavage of the rock, which seems is pretty close to bedding. It's actually more vertical. The dip on this is not as high as it is on the meta-igneous. It's a little shallower. Now there is cross bedding. So what I'm gonna do here, because I don't know if this stuff has been jostled out of place or not, is I'm gonna take a measurement right up here, because I know that's in place. Then we're gonna go up there. We're gonna walk this way. Okay, hey, this is the kind of stuff you gotta be careful of in the field. You see this here? When they cut this out, a lot of this pushed forward. Not enough to get it to fall, but enough to push it forward. Now the stuff that's on the, west wall over there is in place because they cut perpendicular to bedding, strike. Here, they're real close to strike. So a lot of this, you can see no wait, that's not a good example here. It's pretty solid, even though I can tell you it's not in place. It's clearly separated from this. That separated from here. Some dirt came down, some more rocks. So this is what I really want to measure here. So I'm going to do that and mark that in my book. Behind me, which is north anyway, so if they keep falling to the south, they're still going to dip to the north. So I got to measure this right here. This is in place. For those of you that watched my Pure Gorge video from a couple years ago in October, you'll know what I'm talking about. It's the same thing. You have to measure in situ rocks in place. Now, these rocks are close to in place, and anybody else would call it in place, but it's not. It's stratigraphically, it's in place. Structurally, it is not. Somebody rock hounding would be like, oh yeah, that's it. It's the same stuff, and they're right. It is the same stuff. It's just I cannot make structural interpretations off of this. I can off of this. So I'm gonna do that. Okay, I was just there. So we're just gonna come right over here. Not that far. We're gonna look at these rocks. These rocks are in place. They did little rock coverage here that was not there last time. The gravel. They must have, looks like they're trying to replace and redo. That pipe, part of that pipe looks new. Anyway, we're gonna look at these rocks here. Now, we're gonna look at the weathered part here. I did this last time. Look at this. You see right here, this looks very, well, I guess technically it's aphanitic, but you look at it and it looks mostly like it's igneous of origin. But I need to check a couple places. It's here, you can see the cleavage, the penetrative cleavage. You know, you gotta be careful for that. You can't mistake that for bedding because it's slightly off. Cleavage dips more shallowly to the north than does the bedding does. Now you look at this here, and it looks like this. See how it's pitted in places? And you see this here, so it's very green. When you keep looking at it, you see what, if your mind is set in sedimentary, you think is grains. But it's not granular. It is igneous. It's just what we call subhedral. Some of it's euhedral. The weathering patterns actually help you a lot here. So, yeah, I'm going to, if you see here, going to measure this stuff and get the extent of this. So you can see here now, you get right here, and the rock changes a little. See it here? You see it here? Right here? This here, you can see some deformation in the quartz, but this here, right here, this is metasedimentary. That's where we just came from, which just was a gray wacky. So we have a little bit of slate between here. So you have, see where the pencil's pointing? That is igneous. That's a gray wacky right there. Then right here is our contact with something that's more slaty. And then we come right here and we get something more igneous. So that's what I'm trying to do here. I'm trying to get a little map going. So yeah, I'm gonna do that right now. And for all intents and purposes, that's a greenstone. Just gonna leave it at that. That is too. This is a slate. So yeah, and you can see it comes down over here as well. See it? And the color isn't going to help you much here, but the weathering surfaces do. Now, that's it. That's the contact, is probably between the two is right about here. So I'm going to take my measurement here, and then I'm going to get down there. And I'm going to go down there by the river. Okay, everybody, I'm at the east end of the outcrop. You do see that there. Now, This is clearly meta-igneous, you know, or greenstone. That probably is down there. We might have more sedimentary up there, but it's covered, so it's not going to matter. And I would love to follow the utility corridor someday. But here's our GPS right now. Just look at that. I'm not logging this in my field book because I think I have it a different time. Let me do this so you can actually see it. Okay, that's it. That's our GPS. Okay, now before I head back behind me to where I originally started with you, I just want to say that if you look this way, the greenstone eventually comes down. Let's see, am I pointing to it? Right there, comes down. We're not exactly trending east-west here. So before, we're about north 70. So as we go here, we're going southeast a little bit, and the greenstone dominate in exposure anyway. The slate and gray wackies are probably still here. You just can't see them because, well, they're covered up. They weather faster. That's another key thing to look for, is how fast the stuff weathers. The greenstone, the individual mafics weather quickly within the greenstone, but overall it's a harder, more solid rock. So it's not going to suggest itself to mechanical weathering as easily. Chemical, yes. Mechanical, no. Now, you can see as we come back this way, you can see we still have slate exposed right here. So our contact is right about there. Now, I measured all of these rocks. You know what? I'm going to show you with my Brenton real quick. Since our contact is right about there, and yes, my Brenton is set the proper declination. You can see, I mean, this is just rough, but that erosion trench is about north 70 west. So that north 70 west is basically our entire strike. About, you know, it's not exact, and I'm going to show you why here in a second, but first I want to show you this right here. See all this quartz? It's up there too. It's all through here. This is the slate. You see it? It's everywhere in this rock. It's more predominant and, sorry, it's hot. It's hot out here. And, you know, what do you call that? Concentrated in the greenstone. But it does occasionally clump in the metasedimentary. Okay, there's that quartz. The greenstone up here, you can see that is not this is not a xenolith. That is some other silicate mineral that concentrated along fracture planes weathering out. It is not quartz, and it seems to only be present within the greenstone. Now, you may notice that the greenstone is very green, as my wife calls that, geology green, because, you know, everything is a grayish or brownish hinge to it. We just, you know, emphasize color, and you can see it's definitely greener looking than our metasedimentary. Now, remember when I said our oh wait, one more thing. Another reason that I can prove this is metasedimentary and not meta-igneous. You see this kind of turbid flow lamination? That's how I know. Now, all this quartz had to be later hydrothermal. Some of it coming up at an angle to bedding, which is roughly this way. So, and some of it following bedding. The contact between the quartz and gray wacky, it's essentially right here. That's contact. See, it gets more slaty up there, and you can tell it's more coarser grained here. The weathering patterns are different. You do occasionally get your slate lenses. See, it comes this way, kind of wraps out that way. This isn't the key indication of a lava flow. This is the kind of thing you get in turbid water conditions. So let's go back over this way. And so there's the contact. It's buried there. It goes down there. So that's your greenstone, probably greenstone, your slates, your gray wackies. And then it comes under here. And there's more slates right there. Sorry, right there. Your gray wackies at the top, or not gray wacky, greenstone. And then we come down here. And now we're more into our gray wacky. That slate unit is probably 6 feet thick, maybe 2 meters most, maybe. And we come this way, we get greenstone. And then we get another sill or thin lava flow. Then we get more slate. Now, I'm going to take you around the corner. We have real good exposure. And if memory serves, there's no igneous rocks there, meta-igneous. You know, I should just describe them as their parent. Okay? So let's go there real quick. Take a look. We'll be done. Remember when I said there was probably some other sort of silicate mineral withering out in the greenstone? Looks to be similar. Probably some sort of feldspar, but it's out of place at all. Here's that pile. Igneous origin, mostly slates. Igneous, it's all derived from here. This stuff is not the gravel up top. That's felsite, felsic rock, igneous rock. But look at this. I got this down here. That's my hand. That thing. Oh, it's not hot. Nice. That there. But we're here for the rocks. Okay, Steve, remember. Rocks. We come around here. Well, not gonna tell you quite right yet. Let me get over here. I've been over here before. I do think I found a gray wacky lens or layer, or maybe continuous from up to the east. East is that way. I'm facing north right now. Well, I didn't hear any sirens, but that water is starting to be released. Hasn't looked like it's been going up yet, but I gotta watch that. I want to take you a little bit down here. You can see it's basically all slate. I want to get some cleavage. That's basically east. You come here, and this very much could be gray wacky up here, but we look at it, and what we see, we look at this here, is, let me find a piece of it. Look at it real. I can't really find it. I mean, this is gray wacky. I'm just gonna call it gray wacky. I think that's what it is. I would have to actually look at my notes, but that's not what I want to show you here. Come this way, we get the slate. All right, okay, here, it's possibly gray wacky. Actually, I'm gonna break it off and see if it's meta-igneous. It looks like gray wacky. It really does. Okay, and then we got to start to get in the slate. Look at that. Isn't that beautiful? That quartz vein running right through this. But let me get my measurement here. The quartz vein comes up here, comes up there, follows a northeast trend, almost east-west, which is off from our bedding. It follows cleavage roughly, but it dips kind of the other way than cleavage. Keeps the south. Cleavage seems to dip north as well. So, yeah. Anyway, it's starting to rush, so you can see more slate and gray wacky. They change, they're inter-tonguing and stuff. Now this here, if there is an igneous unit, it would be here, but it's a small tongue. I think it might be, see how it is right there? And I'm gonna get it real quick and measure it, and then the rest is slate, and I think they have a gray wacky down there, and then I'm getting out of here, because yeah, it's starting to rise a little. Okay, tip for me taking notes on loose rock. Oh yeah, somebody forgot their sunglasses. Yeah, I don't wear sunglasses. But here is the dam to my north. We come this way, and we start to see more slates with little lenses of gray wacky, and possibly even beds of lava no more than, 30 centimeters, like a foot. But right here in this ravine is gray wacky, and it's gray wacky here too. So let me get down back to my bag, and I'll take you through it, and I'm out of here. So I took a lot more notes than I wanted to here. Anyway, that's about where the gray wacky ends. You get slate. So we're gonna head slowly south. I'm still looking east, towering shadow, and we're in the slates again. Now, I did not take any samples because I have done that before here. So I had a lot more time today. I thought I'd do a lot more detailed stuff. So yeah, that's behind me. I'm facing south. I'm gonna take you south now. That's looking due south. You can see the slates. See them real good. Now, our beds dip to the north there. And remember, we're north 70. We changed to about north 80 west here for strike. See, it's definitely slate. It's hard to argue that's not. And then we get, let's see, yeah. Anyway, we get over here. If I can get over here without falling down. See, this is covered and I hate it because it's covered. But this might be a lava unit right here. That would be near the bottom. This would be near the top. See how it kind of changes real quick right there. But it's about 13 feet or a little over 4 meters thick, I think. That's what that is, around 4 meters. But I'm gonna call it lava for now because it looks crystal and under hand lens. So we get back into slate here. And we still have dipping beds north, but somewhere over there, it switches south. The dip for a tiny bit before going right back to north. So it's probably just a local thing. And it's not an error on my part, measurement strike or dip. I made sure. Now this, you know, that more follows the cleavage. So assuming my face is the ground and that way's west, our main strike and dip is from about north 60 to about north 80 west. And dip is to the northeast, okay? Now our cleavage is about north 70-ish east and dipping south. So, oh wait, is it dipping south? I'd have to look at my notes. I think it's also dipping north. Yeah, it's dipping north as well. So it's a little hard. So that penetrative cleavage is close to bedding here, which tells us about the structure. But I think all in all, we are probably on a limb of some large fold here. So I'm gonna go back. Anyway, I think that's it. If you have any questions or comments, please leave below. I hope you learned something.